Hello, geometry students. This is Mr. Allen. Today we're going to start chapter 3, and we're going to look at section 3.1 specifically, which is on lines and angles. Okay. Let's try that again. Okay, going forward. Sorry about that. The objective here is to identify relationships between figures in space and to identify angles formed by two lines and a transversal. So our first definition is that of a parallel line, which we've already looked at. We have parallel lines that there are two lines that are coplanar and they do not intersect. We use if you look at the diagram here, we've got several lines and planes drawn, endpoints are labeled. And I could say that line AD, so I'm going to write AD with an arrow over it, double-headed arrow, we would say is parallel, so we use two vertical marks like that, to line BC. So those two lines are parallel. The reason that we know that they're parallel is because they are in the same plane. That means they're coplanar, and they don't intersect. And we also know that they are parallel because you see how there's two extra arrows marked on those two lines. So those two lines are parallel. Similarly, we could say that these two lines are parallel because they have a set of extra arrows on them as well. So whenever we want to show that two lines are parallel in a diagram, we have the two lines drawn. We usually add an extra set of arrows like this. All right, so the next thing is skew lines. We've actually talked about those before. Skew lines are non-coplanar and they are not parallel and they do not intersect. So for example, consider the line AD again. Line AD. So we need to find a line that's not in that plane, and it can't be even in a parallel plane. So we'll say this line right here. So we've got line AD and line BF. Those two are what we call skew. They are not coplanar, they are not parallel, and they do not intersect. They do not have any points in common. There are many other examples in this diagram as well. Parallel planes. We've talked about planes before. Parallel planes are planes that simply do not intersect. So here we could say that plane A, B, C, D is parallel, vertical bar, plane, what do we say here? E, F, G, H. So the brown plane on the top and the brown plane on the bottom, those would be parallel planes. They do not intersect. All right, so let's go ahead and look at some examples. I'm going to move my picture there a little bit out of the way. So we've got this, looks like a prism here. You can see there's a number of points and segments. And I should also mention that if we say two segments are parallel, then you're basically saying the lines that are formed by those segments are parallel. So question A says, identify at least two segments parallel to segment AB. Okay, so they have to be in the same plane and they have to be parallel. Okay, so we're going to kind of make some assumptions here because you'll notice there's no double arrows. But I hope you would agree that segment CD is parallel to segment AB. You'll notice that both those segments are in the top plane and they appear to be parallel. We could also say, what would be another one? So what if we think about that vertical plane there? What about, or that segment EF? And that would be parallel to AB as well, right? So they are in the same plane and they do not intersect. So there's a couple of examples. 2, or B, what are some segments that are skew to CG? CG. Okay, so CG's over here, and I want to find a segment that's skewed to it. So that means that it can't be in the same plane and it can't be I'm going to say AB. I think AB is skew to CG because AB over here, that's in a separate plane and it is not parallel to CG. Can you think of a different segment that would be skewed to CG? Let me give you an answer that is incorrect. In fact, I'll do it in blue. Here is an answer that would be incorrect. AE, segment AE. That would be incorrect. Can you explain why? Why would segment AE, this guy here, not be skewed to CG? Okay, C. Which plane is parallel to BCGF? Okay, BCGF. Do you see that plane? Let me highlight it for you. That's this plane back here. That's the back of the box, if you will. There's plane BCGF. What plane would appear parallel to that plane? Well, the plane that's parallel to it has to be the plane in the front. So I would say plane, oops, still on a highlighter here, plane ADH. So the plane here in the front, this guy, I would say that that plane is parallel to plane BCGF. And finally, name a segment that is parallel to segment. So this one, they want us to give a segment that's parallel. So what would be a segment? I probably need to clear off some of this stuff here. Let's erase all this stuff over here so we can see that better. Okay, first of all, let's kind of highlight the plane. EFGH, so that's the bottom. So that's this guy here. What would be a segment that's parallel to that? I think that segment AD is parallel. And the reason that I would say that is segment AD is in the plane that's parallel to plane EFG. So I think that segment AD. And there are other examples. Okay, so now let's talk about something called a transversal. So here I have 3 lines drawn. Let's call this line A, line B, and we'll call this line L. And line L would be an example of a transversal because it is a line that cuts 2 or more other lines in the same plane. And by the way, you'd agree that they cut here and they cut here. And they do so in distinct points. Yep, those are different ones. So this, we could say that line L is a transversal for this one. I'd also like to note the following, that this area in here, we would call that like the interior. That'd be like the interior of those lines, right? So then what would you probably call this stuff out here? Like out here, I call that the exterior, and even down here is the exterior. And I'm going to use that information as we move forward into our next slide. Okay, so we have 4 special angle pairs that we use or name when we are talking about angles formed by transversals. So I've got there's 2 on this slide, there's going to be 2 on the other one, and so there's 4 total. So the first type is called alternate interior angles. Alternate interior. So interior, we just talked about on the previous slide. This is the interior, right? So it has to be it has to be these guys in here, right? And alternate just means that they're on opposite sides of the transversal. So let me go ahead and see if I can highlight this angle. Oops, that's not going to be good. I'm going to erase everything on this particular. I'm going to move my picture out of the way here a little bit. I'm going to erase everything on here. Okay, try this again. Angles 6 and angle 4 are alternate interior angles, angle 6 and angle 4. And so that example is given right here. And the reason they're called alternate interior angles is, first of all, they are on the interior. Well, that's no big surprise. We already talked about what the interior is. And they are on alternate sides of the transversal. Another example here of alternate interior angles would be angles 3 and 5. Okay. The next type of angle pairs that we have are same side interior. So again, they are interior, just like the last one, but now they have to be on the same side. So it should kind of make sense that angles 4 and angles 5 would be same side interior. And similarly, angles 3 and 6 are going to be the same side interior because they are inside of the other two lines and they are on the same side of the transversal. So we've got alternate interior, same side interior. Okay, so now here's the other two pairs that we need to look at. I'm going to start with this one down here. Let's start with the alternate exterior. So we just looked at alternate interior, or same side interior, right? We've also looked at alternate exterior. Alternate exterior angles, well, that means they're going to be on different sides of the transversal and they have to be exterior. So angles 1 and 2 are alternate exterior angles. Angles 2 and 8 are alternate exterior angles because again they are on alternate sides of the exterior of the transversal and they are exterior to the lines M and L. And finally, corresponding angles. This one I think is probably the most intuitive. The way I like to think of corresponding angles is, imagine if I could pull line L right down on top of line M. If I could, which angles would match up? Well, I would hope you would think that angle 1 and angle 5 would match up. And here's the reason we call them corresponding. Would you agree that if we consider this point of intersection here and this point of intersection here, so we'll call this up here, let's call that, I'll call that point P, and then down here we'll call that point S, okay? At point P, would you agree that angle 1 is, if you will, above and to the left of that point? Same thing for angle 5. Angles 2 and 6 are corresponding because they're both above their corresponding line and they are on the same side of the transversal, so they're corresponding angles. So the four types of angles that we're worried about are alternate interior, same side interior, corresponding, and alternate exterior angles. Our final example today is based on the diagram on the right. Hopefully you'll notice that I have a transversal and a couple of other lines drawn and all the angles are labeled. It says identify examples of the following: alternate exterior angles. So if I were you, I would encourage you to pause this video and write down some answers. Now I just want at least one answer for each. If you give me more, that's fine, but give me an example of alternate interior, give me an example of same side interior, give me an example of corresponding, and then an example of corresponding exterior. Or you can just watch me explain what they are, and that'd be okay too. Okay, so here we gotta be careful because the diagram is a little bit different than the one on the previous slide. The first thing that I recommend that you do is identify your transversal. Here's our transversal, okay? Notice the transversal intersects those other two lines in distinct points. So let's go ahead and identify our same side interior. So alternate interior. So they have to be on the interior. Remember, I'm going to put the interior here as yellow, okay? So make sure I'm on yellow. I'm not. So this is the interior, right? This is the interior between the lines. And then everything on the outside would be exterior. So they have to be interior and they have to be alternate. Alternate means they have to be on opposite sides of the transversal. So angle 2 and angle 6 are alternate interior angles. There's another example of alternate interior angles, but that's one example. Okay, same side interior. So again, they have to be interior and they have to be on the same side of the transversal. the same side of the transversal. So you could say that angle 7 and angle 6 are same side interior. There's another example of those as well. Corresponding angles. Now this is the harder one. I think it's easy, but it's, for some reason it's a little bit challenging for students. So the way I like to think of, if I could pull line M right on top of line N, corresponding angles would correspond to one another. So for example, angle 1, which is right here, what angle would that correspond with on the other intersecting lines? I'm hoping that you can see that that would be 3. In fact, let me give you one more example of corresponding angles. Here's another example of corresponding angles. And I'll just leave this one for you. What angle would be corresponding to angle 7? What angle would be corresponding to angle 7? And then finally, D, alternate exterior angles. Alternate exterior angles. So now what we need is we need our angles to be on the outside, no longer on the interior, and they have to be alternate. So that means they have to be on opposite sides of the transversal. So one example would be angle 1 and angle 5. Angle 1 and angle 5. These two angles are exterior, and they are on different sides of the transversal. And I'll give you another one here. There's a couple more examples. But what angle would be an alternate exterior angle for angle 4? So I'm just going to leave those two for you to figure out on your own, and that will end our discussion for today.